Today, the Arctic region is home to as many as 10 million indigenous and migrant residents. But climate change is posing severe threats to the sustainability of Arctic life. Wildland fires are leading to increased air pollution and new health problems, while thawing permafrost is degrading existing infrastructure. Renewable energy is beginning to play an increasingly important role in the Arctic economy, but the region continues to rely heavily on fossil fuels. Tourism represents a possible new industry for the Arctic, which could create jobs and build new wealth in the far north. But cities are still facing important, everyday challenges in realms such as housing and waste management. In the following video, you'll be introduced to a variety of research projects from the Arctic Partnerships for International Research and Education research network based at the George Washington University. These research projects, which are designed to evaluate urban sustainability practices across the Arctic, can ultimately be used to identify and promote best practices in pursuit of greater urban sustainability across the Arctic region.
Our research goal was to construct a database looking at urban sustainability across 46 cities. So for 3 years, we collected data to populate a global framework called the ISO 37120. And while the framework was helpful in gathering and concentrating a wealth of data related to sustainability, it really only serves as the beginning of an effort that needs to include a multitude of perspectives, and especially those of Arctic residents. So as we know, these cities are extremely unique and they face heightened challenges around climate change. So any type of metrics for them need to be placed in the context of lived experiences. For instance, indigenous knowledge production and sharing networks are often incommensurable, but they are crucial to any type of productive conversation around sustainability. As you will hear from members of our research team, these indicators mark only the beginning of our investigation. And to highlight their complexity and context, we emphasize the need to embed these metrics within other research methods to better understand how all elements of urban life are interconnected.
To better understand the ways that our indicators connect with one another, we use data analysis to guide and support our research. One benefit of gathering data to measure 128 indicators across 46 cities is that we have nearly 6,000 data points. That's a lot of data to work with, and this makes it possible to begin teasing out the relationship among various components of sustainability. In recent studies, we have used quantitative methods such as principal component analysis and regressions. One of our most interesting findings so far was that voter participation is strongly correlated with better solid waste management. In other words, the more that Arctic residents participate in their political systems, the better rates we see for trash collection, landfilling, and recycling. The data we collect on health, education, urban development, recreation, and many other components give a valuable snapshot of life for Arctic residents. It is not enough to look at the output, but is necessary to have knowledge on the background of Arctic cities in order to understand the story that the numbers are telling.
One of the major issues with having over 6,000 data points is answering the question, how do we publicize the data? More importantly, how do we share this in a way that is relevant and accessible to all residents of the Arctic?
In order to accomplish this task, we have decided to organize a website by combining Tableau with Weebly. This allows anyone with internet access the ability to interact with the data to better understand how indicators can inform urban sustainability practices. Furthermore, if web users have better data, they can reach out to us directly to propose updates, allowing us to prioritize accuracy in line with the rapidly changing conditions of these cities.
The incidence and severity of wildfires has increased significantly in the Arctic over the last few decades. These wildfires are caused by droughts, lightning strikes, and human activity, and have drastic consequences for the health of humans and wildlife. They also impact the environmental and economic resilience of the Arctic. We're studying the fire management ecosystems in these areas by comparing firefighting practices, administration, and communications across populations with varying degrees of risk perception and reliance on government. By looking particularly at Sweden, Alaska, and Russia, we can compare how local and regional factors impact how wildfires are handled. This research also examines how the public perceives its personal responsibility in preparing for fires by evaluating geographical, economic, and political differences across the Arctic. Understanding these differences is crucial in order to determine which practices work best, as well as how governmental, volunteer, and other agencies can collaborate to keep their populations safe.
Wildfires and natural disasters often pose health and safety risks to Alaskan residents. How can we best communicate important information about wildfires to Alaska's citizens? Different people get their information in different ways. Part of our research effort seeks the best ways to reach out to those who get their information primarily through social media and the internet, as well as those who seldom go online. We have tried to visualize the data describing these different audiences by drawing composite portraits of them. Using digitized hand-drawn graphics rather than pictures created solely with computers will hopefully draw attention to the research. It also makes clear that this project seeks to spread awareness to all of Alaska's citizens, regardless of how they obtain their information.
Permafrost, or soil that has remained frozen for at least 2 consecutive years, is thawing due to Arctic climate change. As permafrost thaws, microbes in the soil thaw along with it, allowing the previously frozen plant material trapped in the soil to decompose. This process releases methane and carbon dioxide into the atmosphere and also contributes to destabilization of critical Arctic infrastructure. The goal of our research is to measure the extent of climate change damage to Arctic infrastructure. To get a sense of this problem, we are using open source images from satellite imagery to catalog and map communication, transportation, and energy infrastructure in Arctic permafrost zones. When we pair this inventory of Arctic infrastructure with construction costs, the result will be an estimate of how much damage governments can expect due to thawing permafrost. This issue will require attention both inside and outside of the Arctic, since oftentimes Arctic governments do not have the necessary resources to replace the damaged infrastructure.
As Arctic cities seek to decarbonize and make their electric grid more reliable, many city managers are turning to renewable energy as a partial solution. High fuel costs, frequent blackouts, and threats to energy infrastructure are a few of the issues leading Arctic cities to seek alternative energy solutions. The difficulty arises with how to integrate renewable energy into the grid in the far north. We are examining renewable energy in 5 Arctic cities: Anchorage, Yellowknife, Oulu, Luleå, and Yakutsk. Our research will look at barriers in those cities with a low percentage of renewables and at the conditions and assets that allow certain cities to be so successful with implementation. We will also look at whether the drivers behind success stories can be replicated in cities that have yet to adopt renewable energy.
Tourism in the Arctic has seen a huge uptick in recent years, particularly on cruise ships. Like melting sea ice and warmer temperatures, these tourists are transforming the Arctic in ways that will have lasting effects for decades. Though there are economic benefits to the increase in tourism, there are many negative impacts as well. Some of these include air and water pollution, environmental degradation, and congestion in coastal towns overwhelmed with tourists. The Arctic Cruise Tourism Project aims to document and interpret ways in which Arctic cruises are affecting local communities. We also work with local decision makers to develop community-defined, data-driven policies in relation to cruise tourism. We're focusing on 5 cities: Juneau and Nome in Alaska, Akiri in Iceland, Bergen, Norway, and Visby, Sweden. As the Arctic moves away from reliance on fossil fuels and mining, tourism could provide a strong foundation for a new economy. Finding ways to minimize the impacts of tourism will ensure this is a viable long-term solution.
Another piece in the Arctic sustainability puzzle is housing conditions. The problem of housing can be divided into many subcategories. A big issue is housing affordability, with high prices often increasing homelessness. Among the Arctic countries, Finland has the best record in addressing homelessness. Over several decades, the Finnish government was able to develop a set of policies called Housing First. We need to better understand the Finland success and whether this example can be repeated in other locations.
While the residents of the Arctic are facing growing challenges from climate change, they also have considerable assets with which to address these problems. Using best practices identified by the Arctic PIRE Research Network, Arctic residents can build upon their existing efforts in order to advance a more sustainable future for the Arctic region.